Hello, welcome to Kelp Algae, and today I made a
Calculator.
in Minecraft. And here it is, the calculator that I made in Minecraft. Yeah, it looks really complicated. I think I have to explain how all of this works. Okay, so, first of all, the way computers work is they take inputs in binary code. So, these redstone lamps, they're binary. So, if it's turned on, that means it's a 1. If it's turned off, that means it's a 0. And there's 2, because these are the 2 inputs. Now this calculator only does addition and not subtraction. I'll add subtraction later, but for now it's just addition. Anyway, so off means 0 and on means 1. So that's so the way computers work is they take inputs of binary and they process them through logic gates, which I have really complicated ones here. And then it outputs a binary number, and this is the output binary number. And same as before, on means 1 and off means 0. So the output for this would be 0, 1, 1, 0, 0, 0, 0, 1, 1. So, yeah, it's really complicated. I'm going to have to explain the whole thing. So, I have this text document here. So when you add two numbers together using regular decimal numbers, you start at the far right and you say, okay, if I were adding 532 plus 281, 2 plus 1 is 3, okay? 3 plus 8 is 11. So you put a 1 and then you carry the 1, and then you add everything here. So 1 plus 5 plus 2 is 8. So 532 plus 281 is 813. Okay. Now, when you add binary numbers, it's the exact same. So, 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 1 is 2, but since you can't have a 2 in binary, 2 is 0, 1. So, you have a 0 and you carry the 1. And then 1 plus 0 is 1. So, 0, 1, 1, 1 is plus 0, 1, 0, 0 is 1, 0, 1, 1. So, 1, 1, 1 is 7. And 1, 0, 0 is 4. And 7 plus 4 is 11. And I'm pretty sure 1, 0, 1, 1 is 11 in binary. So, yeah, it's 8 plus 2 plus 1. So this is 7 plus 4 is equal to 11. So, let's head back into Minecraft real quick. So, there are 3 types of logic gates that you use. So there's 3 right here. So this is a NOT gate. So if I turn this on, if I turn it on, the lamp is off. If I turn it off, the lamp is on. So it's whatever the opposite is. Now this is an AND gate. And so you add two signals, and it only turns on if both of them are on. So here we have it's on because both of them are on. If one of them is off, it's off. If the other one's off, but this one's on, it's still off. And if both of them are off, it's off. It only turns on if you turn both of these on. So this is an AND gate. It takes 2 signals and only outputs a signal if both of them are positive. And then OR is pretty simple. If one's on, it's on. If the other's on, it's on. If both of them are on, it's on. It's only off if neither of them are on. So those are the 3 gates. Now, how do we apply this to addition? So, if you're adding 2 bits together, or 2 binary digits, so you can either have 1 plus 1, 0 plus 0, 1 plus 0, or 0 plus 1. Now, if you add 1 plus 1, it's 0, carry the 1. And then, if you add 0 plus 0, it's 0 without a carry. And if it's 1 plus 0 or 0 plus 1, it's 1 without a carry. So, in order for the output to be 1, there needs to be a 1, but it can't be both of them. So, this is what I created to make that. This is an exclusive OR gate, which means you need to have at least 1, but it can't be both. So if I turn 1 on, that's on. If I turn the other one on, it's on. If both of them are on, it's off. So you need to have at least 1, but you can't have both. That's an exclusive OR gate. So this is how I add 2 digits together in the calculator. As you can see, there are a ton of different copies of this gate throughout the computer system. So anyway, also, you can't just get the output of the 2 bits being added together. You also need to give the number that gets carried. So, if you look over here, it only gets carried if both of them are 1s. Because then it's 0 carry the 1. So if you head back, I have this extra current coming off the end. And this current only gets activated if both of them are on. So I turn one on, it's off. I turn the other on, but this one's off. It's still off. But if I turn both of them on, it's on. So this is what's called a half adder, because it takes 2 bits together and it adds them together. And it's called a half adder because you need 2 of them. And I'll explain that over here. So, now this is the computer system. And it's just a bunch of half adders added together. They're called half adders because you need 2 of them to add 2 bits together. So, here's the first half adder. What this one does is it takes the signals from the first, no, not the first bit, the last bit of each input. So look, over here, the last bit of this input, if you follow the signal, it goes to this half adder. And the other signal coming into the half adder comes from over there, which the last digit of that input. And what it does is it takes the 2 bits and adds them together, and whatever the output is the last digit of the output, which is right here. Now when you carry, whatever gets carried goes off to the side, like it did over there, and it gets added to the input, it gets added to the output of the next 2 bits being added together. And that's why you need 2, because you not only do you have to add the 2 bits together, you also need to add what gets carried to the output of the next 2 bits. And the output of that just gets taken over to the next to last digit of the output. Because once you take the output of the first 2, no, the carry of the first 2 plus the output of the second 2, then that's how you get the second to last digit. And it goes all the way down the line. So now here's the third to last, being added with the carried number from the second to last, and then going to the third to last of the output. And it's every single one until you get to the very end. And if it gets carried off, it doesn't add with anything because there's not another digit for it to be added to. So it just goes here, and it just becomes the first, because you do it backwards. Anyway, so this is very complicated, but does it actually work? And yes, it does. So let's do some very simple addition. So I'm going to turn all these off. So both of the inputs will be 0, 0, 0, 0, 0, 0, 0, 0, 0. And this is an 8-bit calculator, which means you can have up to 8 bits of data. So the highest numbers that you can add together are 255 plus 255. Because 256 would take 9 bits, which we don't have. So right now it's 0 plus 0, which as you can see is equal to 0. Now let's do some very simple addition of 1 plus 1. Okay, so obviously it's backwards because I have to go around this way. Now as you can see, 1 plus 1 is 1, 0, or 2. So 1 plus 1 is 2, according to this calculator, which, yeah, it is. Now if you do 1 plus 2, as you can see, it's the last 2 lamps that are on, which is 1, 1, or 3. Now if I do some really complicated stuff, so like, turn on a few random ones, and then turn on a few random ones over here. Now, I can't do this in my head, so I'm going to have to use a calculator. Hold on real quick. Alright, so I've done the calculations, and this number, 011010001, is 105. And over here, 011001110 is 102. And if you add them together, it's 207. And 011001111 is 207. So, this calculator does work. And right now it can only add digits together, not subtract. I'll do that in the future. And it only works with binary numbers, so there's no way to convert between binary and decimal numbers. So, right now it's pretty bad, but this is the best thing I can do for now. So, until the next video, goodbye!